Conventional systems use conductive breaker points in the distributor to turn the switch on and off mechanically, just like this device. But today, most systems make use of the switching effect of a transistor, or an electronic control unit, or ECU. Now let's take a close look at how a high voltage is generated using an actual transistorized ignition system. An ignition coil, a signal generator, and an igniter are integrated with the distributor. In the transistorized ignition system, the ignition signal from the signal generator is transmitted to the transistor in the igniter. This transistor turns the primary current in the ignition coil on and off. The signal generator has three components: a signal rotor, which makes one turn for 2 revolutions of the crankshaft, a pickup coil, and a permanent magnet. The rotor turns clockwise or counterclockwise depending on the engine. As the rotor turns, a voltage is generated in the pickup coil. This is the ignition signal. But why is a voltage generated? The magnetic flux of the permanent magnet flows through the signal rotor, the pickup coil, the bracket, and returns to the magnet. When the rotor is still, there is no change in the magnetic flux. When the signal rotor rotates and a rotor tooth approaches the pickup coil, the magnetic flux density increases. As the rotor tooth moves away from the pickup coil, it decreases. This means that the voltage generated in the pickup coil depends on the changes in the magnetic flux. The level of EMF generated depends on the relative positions of the rotor and pickup coil. When a rotor tooth approaches the pickup coil, the EMF increases, and when the rotor tooth and the pickup coil face each other, it becomes 0. When they move apart, a counter EMF is generated. These changes in the EMF cause the igniter to switch the primary current on and off. Let's take a look at how the current is turned on and off. The engine is running and signal rotor approaches the pickup coil. The voltage is generated in the direction shown in the diagram. The base current flows in the transistor switches to on, and the primary current flows in the coil. When the signal rotor's tooth is aligned with the pickup coil, the voltage generated in the pickup coil decreases and the transistor is turned off. This cuts off the primary current and generates a high voltage in the secondary coil. The transistor is also turned off when the voltage is generated in the opposite direction in the coil. In this way, when the engine is running, the transistor is turned on and off every time one of the signal rotor's teeth passes the pickup coil. Every time the transistor is turned off, a high voltage is generated in the secondary coil. The voltage generated in the secondary coil then passes from the distributor's center electrode through the rotor and from the outer electrode to the spark plugs, according to the firing order of each cylinder.